In this video, we will look at how can we include the categorical variable in our multiple regression model, and also how can we get the regression analysis for our multiple regression model, which include the categorical variable. In this example, we look at what will affect the GPA. So we propose that the age of the student and the class standing should have a correlation with the GPA. That's why we collect the 7 observations. So the first column, column A, is our y variable, dependent variable y, GPA. And column B is student age, which is quantitative variable. And the second variable is our class standing. And so for class standing, this is a categorical variable. So the first question you need to ask yourself is, how many levels do we have here? So for class standing, we have freshman, sophomore, junior, and senior. So we have 4 levels. And based on the concept in our chapter 15, and we will know that if we have the categorical variable with the k levels, and we need to add k minus 1x to our multiple regression model. So to apply that theory to this example, and since the class standing have 4 levels, and we need to create 3x and to add to our regression model. So how can we create those 3x? So that's related to our very important step. It's called make the code for a dummy variable. The definition for dummy variable indicate that the possible value for dummy variable can only be 0 and 1. So in that case, let's first create our define our dummy variable. So our dummy variable has, let's starting from x2 because x1 already taken by age. So we have x2 stands for freshman, and x3 stands for sophomore, and x4 stands for junior. And as we mentioned, we have 4 different levels. First is freshman, and sophomore, junior, senior. So we have 4 different levels. So for freshman, we know x2 represents the freshman. So the value for x2 is 1. And we know for x3, we define x3 stands for sophomore. So x3 for sophomore is 1. And we know for junior, and x4 stands for junior. So the value corresponding to junior is 1. So if we have an observation, he's a freshman, we will have x2 equal to 1. Since freshman is not sophomore and junior, so x3 equal to 0 and x4 equal to 0 as well. And for the sophomore, since sophomore is not belong to freshman, so x2 equal to 0, x3 equal to 1, and x4 equal to 0. For junior, and we know for the junior, if he is not belonging to the freshman, which is 0 for x2, is not belonging to a sophomore as well, so x3 is 0 as well. But the x4 stands for junior, so x4 is 1. So how about the last level, senior? So since senior is a none of 3, so all 3 values equal to 0. x2 equal to 0, x3 equal to 0, x4 equal to 0. So now you will find, except the last level, senior, all the level, freshman, sophomore, junior, will satisfy the condition that at least only and at least one x equal to 1. So that's why x2 equal to 1, but x3 and 4 equal to 0. So obviously, senior, our last level is very special because for the last level, all 3x equal to 0. So we will call this level as basic level, which will, the reason we define the basic level is because we will use the basic level to help us to do the interpretation for partial coefficient corresponding to our dummy variable. So now we can start to code our observation based on our definition for the dummy variable. So we will add 3 more columns for x2, x3, and x4. So now let's look at the first observation. So for first observation is a junior. So obviously junior we got the code is 0, 0, 0. So you type in 0, 0, 0. And for the sophomore, the second observation is sophomore. Then you go down to look at if it's sophomore, the code will be 0, 1, 0. 0, 1, 0. So now the question is, in this case, we only have 7 observations. It's relatively easier for us to fill in the dummy variable one by one. However, think about if we have 50 observations, how can we fill in the dummy variable for our observation? There is a smart way to do the coding for our dummy variable. So first, select our data set, including the labels, and then click Home and find Sort and Filter and choose the filter. After you choose the filter, you will find for column A to column F, there is a little arrow on each labels. So now we are sort the data, filter the data based on our class standing. So for instance, we only choose freshman. So we left the 5th, 5th, and 8th observation. So based on our definition for our dummy variable at the beginning, and we will know for the freshman we will have x1 equal to 1, 3 and 4 equal to 0. So what you can do is type in 1 and drag down, because all these 2 observations share the same characteristic for class standing. All of them are freshmen. So if they are freshmen, x2 equal to 1, and 3 and 4 equal to 0. And 0, select the first row and drag it down. So we finished the dummy code for our freshmen. So now let's look at the second level, junior. After you click junior, we have these 2 observations left. So for the junior code, we have 0, 0, 1. So we will fill in 0, 0, 1 for first row, and then select first row and drag down to the second row. Then we finish the dummy coding for the student who is the junior. So let's find the third level, senior. So for senior, we've already identified our first senior is 0, 0, 0 based on our definition for dummy variable. Then we select the first row and drag it down. Then we finished the dummy coding for the senior student. Now let's choose the last level, sophomore. So we only have 1 sophomore, so we've already made the code. So now you finished the dummy coding for our data set. Now you want to ask me, where is the data? So you need to go back to the home, sort and filter, and close the filter. So now you can see the original data set with the dummy variable you just coded. So now we can, before we start to use data regression analysis, you need to pay attention on the x variables. So we totally have 4 x, x1, x2, x3, and x4. Unfortunately, the column C is separate the x variables, separate x1 from x2, 3, and 4. So there is a default setting for Excel. In order to use the regression analysis, you need to make sure all the x variables are next to each other. So which means you need to delete this column. So after you delete the column which separated the x1 from x2, 3, and 4, and we can start to use data analysis. So first click the data, find the data analysis, and go to regression. Click OK. Then we can choose our Y range. Click this little icon, select A1 to A8. make sure you choose the first cell, which is the label for that column. And now we can choose X range. So it's different from what we've learned in the simple linear regression model, which we only select one column. Now we select all the columns for X. So we will select from B1 to E8. So this whole area is for our X variables. Then click this little icon. Since the first row is the label, so you need to check label and place the outcome in the new worksheet called regression. And then check all the box 1, 2, 3, 4, 5. So we totally have 5 boxes, and you need to check all of them and click OK. So now you will find you have one more new page called regression. And on this page, it lists all the outputs related to the regression analysis and also many different plots. So in the next video, we will look at where to find the statistics to answer our analysis question. And the second is how can we use those plots to do the diagnostics. And before I end this video, I want to mention, so it's a good habit every time you got the data analysis output, try to set up the format of your cell. Like for instance, I keep 4 decimal places. That's what I usually do. And click format, select all the column from column A to the column I, and right click your mouse, choose format cells, and then choose the number. And here you can choose how many decimal places you want. I usually do 4. And click OK. So now the Excel help you to keep the 4 decimal places for all the statistic output. So in next video, we will look at how can we find the proper statistics to answer our statistic regression question.